Hi everyone, and today's example we are going to go over a supermesh problem. Specifically, we are going to try and solve for the current I naught that goes from left to right across this 1 ohm resistor. Okay, so as with any supermesh or any mesh analysis problem, we'll first identify the total number of loops. I see 3, 1, 2, and 3, so I'll go ahead and label my mesh currents now, ignoring that pink I naught for now. So I'll call this one here I1, I2, and then the one on the right I3. And then now I'll start writing out the mesh equations. And I'll start with I1. So starting with I1, I'll start with this resistor. So the 2 ohm resistor feels the current I1. And then we go through the 80 volt independent voltage source from the plus side. Since it goes through the plus side, I put the plus sign there. So plus 80. And now it's the 4 ohm resistor, which feels both the I1 current as well as the I3 current. And so since this equation is with respect to I1, we use a positive I1 and a negative I3 in this expression. And then similarly, we now have the 1 ohm resistor, which is here. It feels both I1 and I2. And then we apply KVL, we set this equation equal to 0, and we call it a day. And then now, normally what you would do in a mesh analysis problem is you would write your mesh equation for I2 and then for I3. But what we notice here is that there is a current source in between the I2 mesh and the I3 mesh. Therefore, instead of doing two separate equations, one for the I2 mesh and one for the I3 mesh, we do a combined equation for the super mesh between I2 and I3. So let's note that here. So we're doing I2, oops, let's see if we can erase that. Okay, so now this equation here is for I2 and I3. I shouldn't say plus, it should say and. And so this is the super mesh. So take note, again, originally or normally you would have a total of 3 equations since there are 3 meshes. In this case, there's a super mesh that combines 2 individual meshes. So in this case, we're going to end up with 2 equations instead of 3. And I'll start with this 5 ohm resistor on the bottom left. Okay, so that 5 ohm resistor feels the I2 current. Then we go to the 1 ohm resistor, which feels both the I2 current and the I1. And again, I1 is negative because this equation is currently with respect to the super mesh, and we're focusing on I2. The next resistor in the super mesh, so before I move on, let me just draw in what the combined mesh looks like between I2 and I3. There it is. And so I'm following this yellow path. Start with the 5, we did the 1, now we're up to the 4. So writing out the expression for the 4 ohm resistor, it feels I3, and then it also feels I1. And again, we're doing this expression with respect to the super mesh, which includes I3. So I3 is positive, I1 is negative. And then finally, we hit that 180 volt source from the positive side. So we'll put a plus sign here, not a negative sign. And then just like before, using KVL, we set that equal to 0, and now we have a total of 2 equations. But in addition to the 2 equations, we have 3 unknowns, I1, I2, I3, so we need one more equation. And so the place from where you'll get your third equation is from that current source that told us to use a supermesh approach to this problem. So you go back to that current source, in this case the 45 amp current source, and you'll notice that that 45 amp current source goes in the same direction as I3. So I've kind of expanded that or redrawn the I3 current, and you can see the I3 current goes in the same direction as the 45 amps, whereas the I2 current goes in the opposite direction as the 45 amps. So we can write out an equation for this. So 45 we can say is equal to I3, and notice that the sign in front of the I3 is positive, and that's because it's in the same direction as the 45, and then we'll subtract I2 because it's going in the opposite direction. So now we have 3 equations, and 3 unknowns, and this can be solved in MATLAB or Python, or you can do it by hand, and then you can compare to the solution here. So you can see the currents are shown, you can see all the node voltages are shown. So specifically, ultimately, we were looking to find I0, which is the current that's going from left to right across this 1 ohm resistor. So let's just quickly say how we would parameterize this value in terms of I1, I2, and I3 for now. So we'll just kind of scroll in here and do the same kind of analysis we did earlier. So we see that I2 is going from left to right. So let me draw that in, draw an additional little arrow sign here. So I2 goes from left to right across this 1 ohm resistor, just like this I0 current does. However, I1 is going in the opposite direction. Therefore, just like earlier with this 48.5 amp current source, we can write out an auxiliary equation. We can say I0 is equal to I2, and then positive I2, because I2, as we see here, goes in the same direction as I0, and then we'll subtract I1. So what'll happen, let's copy that. What'll happen is you'll solve this equation, or this system of equations for I1, I2, and I3. Really all you need is I2 and I1. You'll subtract them from each other, you'll get the value of I0, and then you can compare to the magnitude of the current, which is 27.11, that's shown as our answer here. Okay, thanks.